levels. So view of the data means what are the various level, at which level we can see what is the perception of the data at the different levels. I'm taking the simple example. Suppose you are a shopkeeper, okay, and I'm a customer. So according to me, this is the product for me which is usual for me. But according to shopkeeper, there is no guarantee, there is no chance, or there is no guarantee the product will be usable for the shopkeeper. But he is selling such product for the selling purpose only, or for getting the benefits only. So the perception from the shopkeeper and customer is different from each other. Same thing we have over here. If you're looking for a database, and database in the computer system are stored into the different aspect. What we have that is the physical level, but computer has on its logical idea, logical manipulation that is to be interpreted by the database compiler. So internally, how it is stored and how it is to be managed, and that is done by the logical level. And since as a inform the output, we can say like, n number of the user we have. Okay, so n number of users can have their own view. Okay, so according to they have the own different views. So n user can have the own view, and own user can see the result into a different way as according to their requirement or their need. So the database system is nothing, basically it is a collection of the interrelated files, and these files are known as the, I'm just selecting this point here for your explanation purpose. These files are known as a table, okay, or in database concept we can say it is known as a relation. Okay, and why it is known as a relation I will tell you later on, but let me define the term over here, a relation and the table, and a set of the program that allow user to access and modify these files. Okay, so in a table we can store the information tabular way. If we need to update such information, so we can update as our requirement. But now question comes in our mind, what is the perception or what is the view of the data, and that is known as the abstract view of the data. Now, this is the my diagram. A student asked me, "Sir, can you explain the data abstraction once again?" So I'm explaining. But before explaining to her, let me know the something from her side. Now, can she tell me what is what is this? Can she tell me what is this?
Sir, I didn't get your question.
Uh, are you able to see this letter?
Sir, B.
It's B. According to this is B, but according to me this could be 8, because now this could be 8. According to me, this could be 8. So as according to you and according to me, the perception is different. So view one and view two and so on. So view n is defining that if user is accessing their information, maybe different, but he or she will get the data from the same pool of the area. So this is a point, but I will explain very brief manner so you will understand. Now, come to the point, logical level and physical level. It is better idea to, I think I should explain data abstraction by the real application, real example, so you will be familiar. Okay. So before going to the ahead part, let me just briefly define this term, that is the data abstraction. Data abstraction means that how data is stored into the database you don't know, because as a user level we know that is only we know what the data we have, what the logic we have. So how data to be stored, that we know only at the user level, means we know, means we are typing the information, we are writing the information in form of the data, we are saving, and it's okay, we know. And but we don't know how actually it is to be stored into the computer system, and what are the process by which that is to be stored, and that is done by logical level. So here, can you tell me, do you have any idea about to ride or drive a car, ride a bike or drive a car, any scooter do you have, do you know?
Sami?
Yes, sir.
Yes, of course, of course, of course.
Yes, sir. I know how
So,
to
okay,
ride a
so
two-wheeler.
ride a two-wheeler. So you know that how to ride a two-wheeler. You know, you know.
Yes, sir.
So okay, so that is known as the physical level, because in the physical level, I know it means you know that how to ride a two-wheeler, and that is a physical level, because you are looking for the physical part of that one, so you can see how to ride. But internally, how engine work, okay, how engine works, and okay, when pressing the brakes and how it is to be, how it is functionized, and then suddenly your scooty will be, or scooter is to be stopped. Do you know internal structure, internal function? Do you know?
Um, no.
No, so that is a logical level that defines that what is the function inside the machine or inside the scooty, how it is functioning, and how it is functionized after pressing the brake or after moving the accelerator from the left side, or sorry, from the upper side or lower side. Okay, so this is done by the engine process only. Then that is known as internal. That's why this logical level is known as the conceptual level. So this conceptual level will be determined by only the database compiler. Here we have the term, we can say is not defined by the database compiler. So at a user level, only the user know the physical level, that how to actually store the data, but user does not know what is the process by which the data to be stored into the computer system or the disk drive or any other form of the data. You don't know. So this is done by the logical level, and here we have the term that is abstraction. So logical level is completely function of the logical level is completely abstracted from the user, and this is my point. Now these two, and these are the two different levels as I discussed. Is it clear to you right now? Tell me, is it clear to you?
Yes, sir. Two level and view level.
Yes. V level I can explain in simple way. I have a simple example. No problem. No problem. I am taking the same example while riding the two wheelers. I can. No problem. But let me know
Yeah.
first, let me know these two different levels are clear to you right now.
Yes, sir.
Okay. In terms of database, not in terms
But
of mechanical engineering.
sir, in terms of riding a two-wheeler, I understood. But in like in
Terms
the
of,
in database.
okay, I just I will take the this part over here. Now see, just now you are creating a table. Okay, you made a table or design a table, that is student table. Okay, and that is a physical level. Did you? Okay, you can do. Now this is done by the user. So student table is designed by the, or student database is designed by the user at the physical level. Now this part is clear to you regarding the database.
Yes, sir.
Okay. Now my next question is saying that what is the procedure? Okay, and what is the function? What is the function by which the actual information to be stored into the database? Now, how this student table or student record or student information is stored into the database? Do you know, or user knows? Just tell me yes or no.
Mm, no, no,
No.
no, sir.
So this no. So this is known as a logical level, because logic of the compiler is own logic, and it defines for only database and how it is to be interpreted, how it is to be stored. So here you can read out over here, this level of the abstraction describe what data are stored in the database. What data are stored means what is the process by which data are to be stored into the database. So you are storing, suppose you are storing your name, then you don't know how the name to be stored into the such table or such or respectively column name. You don't know, and that's why it is known as a logical level, or it is also known as a conceptual level. Now, in terms of the database, is it clear to you?
Yes, sir.
Now these two different labels are clear to you.
Yes, sir.
Okay. Now come to the point, view 1, view 2 and view 3 and so on, so view 1. Let us explain this concept through your example, that is riding a two-wheelers. Okay. You have a one two-wheelers. Now in your family, how many members are? Let me know.
So 4.
Okay, four. Along with you. Okay. So you and your brother, maybe your sister or father and mother. I'm taking. So I'm assuming there are the five. Okay, I'm assuming because I can't say. So I'm assuming there are the five members, including you. Okay. And riding
Yes.
a okay, riding the two wheeler, riding the same two wheeler by your brother is different. Okay, he is just he using your scooter or a two wheeler, and he is running very fastly, approx around 70 to 80 kilometer per hour speed. But your sister is not have is not have the ability to run this kind of the speed. So she can only do she can maintain only 30 to 40 speed. Same scooty just maintained by your sister and brother in different speed, and this is represented as this is known as the view. Okay, according to your brother, this scooty is very easy, I can easily ride. So 70 to 80 speed doesn't mean for me. But your sister is very not shy nature, but she is very you can say scary kind of the people. So she can't run past your scooty. So she only maintains the 30 to 40 speed. Same thing, it is also maintain. It is also happened by your father and you just maintain speed. So same bike and same car, if anyone has, so according to different people, they maintain their speed to handle the car or bike. So they have their own view. So this is known as the view level. Okay. So this is my point. This is an example of the same example. Now is it clear to you?
Yes, sir.
Okay, now I'm coming to the now database term. Suppose on the Google database we have. Okay, on the Google database we have. Suppose we have the X database by the Google. In this database, you need to see the some information which is relevant to your education purpose. Okay, so you have search out. But in this database, some other information like movies information is also stored. But your brother is always like to watch the movie. Then he is fond of the movie, so he will look for the movies. So from this database, another information he is looking for the movies. So what happened from the same database, according to the different people, different users, they have the different view, but we have the same database. So this data abstraction level is defined that how data to be stored is different from what data to be stored and what is the function by which data to be stored. And if we have the n number of the user or number of the people, then if you are accessing their information, then to access the information by each and everyone is will be different or maybe different. So this is the level of these are the concept which shows that level of the database, or we can say data abstraction level. So these are the most important part for learning the database. This is my point with an example. Now is it clear to you?
Yes, sir.
Okay, so according to the BTOP, I'm taking real example. BTOP is only the one database, but the faculty can access only the student database and own database. Faculty can't see the other faculty database. Student can't see the other student database information, not database information. Faculty can see only the student details, but student can't see the faculty's details. And faculty can't see the another faculties. Student can't see the other faculty. So they have some privileges. But according to this level, we have a different view. But we are accessing the same database. That is the beta of database. Now this level is clear to you right now.
Yes, sir.
So this is the most important part today. I said discuss with you, like the data abstraction. Now, if this diagram is clear to all, then I can move to my next slide. Now, shall I move ahead or any doubt? Please, you can ask me. Yes, please tell me.
No doubt, sir.
No doubt. So, the real example I am taking for explaining this database concept, and I will take all time the real kind of example. So, should I go through the such kind of the phenomena for explaining the database codes, or should I use any other mechanism? Please tell me. Because I have more than 13-year teaching experience, so I can teach in different ways. So you can ask any question, but that should be meaningful. So that's why I'm asking once again to all. Should I go by this concept or should I go by this way to explain this database course? Now tell me please.
Yeah, this is good, sir.
Okay, so I'm just moving to my next step. Thank you for once again to all. Now, instance and schema. I have written the lots of theory over here, but this theory can be understood by you in simple example. I have real example over here. I designed this PPT to all for benefit purpose. Now read all the statement very properly. Okay, so I'm speaking by over here, and you can read all the statement carefully. Let me explain these two terms, that is instances and schemas. Database change over time as information is inserted and deleted. It means in the database, if you try to insert some information, so what the time you have at the time you're trying to insert or delete something, that is known as the instance. Okay, that is known as the instance, or we can say it is movement of maintaining the database. So this term is known as the instance. So you can read out over here. In the first point, you have entered out the instance. I've summarized over here. Yes, please tell me. You can please read all these points along with me. So databases changes over time as information inserted and deleted. The collection of the information stored in the database at a particular moment is called an instance of the database. So while after the 2 days you found that is this people is not suitable for you, or this people is not your friend, then you will remove. Okay, from the Facebook or Instagram, from other places, you will try to remove your such friend which is not suitable for you, which is not your actual friend. Okay, so at that moment is what? At that moment is known as stance. Now this point is clear by the real example. Just please tell me
Yes,
yes or
sir.
no. Okay. Now is it clear to all the definition of the instance?
Yes, sir.
Okay,
Yes, sir.
now come to the point of schema. Schema words determine that is a representation of your database, or we can say layout of the your database. The overall design of the database is called the database schema, and schema are changed infrequently. If at all, the concept of the database schema and instances can be understood by the analogy to a program written in a programming language. So once we have defined the database, then or we have defined the database as well as we can say define the table of relation, then once it is defined, then we can update or we can alter. But if you're trying to alter or update, then definitely something will be changed. So you are not allowed to update, but if time permits, then we can update. But what are the structure or what are the layout which is represented by the such database, that is known as the schema. Schema synonym you can understand over here. That is, I'm talking about the structure and layout of the such table relation, or we can say database. So this is the sense. Here I have a real example through the MS Access. So from the MS Access very beginning, very simple tool I'm using right now for explaining purpose. So I just prepared what I did. I just created student record. So in this student record, I have the few fields name. Those are the first name, last name, email address, student ID, and label. And that means junior, senior doesn't mean for me. A room number in which student has to take the class, and special circumstances, or we can say special category, what she or he will be. So first name, that is the Viren, that is my name. I just put the last name for making the myself as a counting to the student page. And Golu and Singh, other I'm taking another example. So I have the two records. Okay, but the question comes in our mind, sir, what is schema? Schema means the layout by which that is to be represented. That is the first name, last name, email address, student ID, level, room, special circumstances. So I can draw all those things like the schema will be like this one. The first name, next we have the last name, next we have the email address. So I'm writing in simple way. Next we have the student ID. Next we have the label. Next we have the room, and last we have the circumstances. So this is known as the schema, or we can say layout of the database or table. Okay, database, you can say database means a collection of the tables, but right now I'm talking about the table schema or relation schema. Okay, so here you need to understand what is mean by the relation schema. But we will should take the this example. Then database schema will be understand in easy way. Why? In a database we have the number of the tables. So this is an example of the table schema or relation schema. But database schema can be this is a database. In this database we have student table, faculty table, okay, and staff table, and admin table, and other different kind of the tables like room information, hostel information, okay. And in this other we have the books record, suppose that we have. So books itself is a tabular information. So in this database, or suppose we can say X database. So in this X database, how many tables we have? 1, 2, 3, 4, 5, and 6. So this is the X database which is consisted by the 6 different tables, or we can say these 6 tables are composed into a single database that is known as the X table or X database. And this X database is represented by the schema. And if you are looking for the table schema, so we have the this part. So this is known as the table schema or relation schema. So table schema I can say. Okay, so this is a table schema or a relation schema. So all be represented by its column name or attribute name. But most of the book, on 90% in the book, database schema will be represented by the table schema itself only. So that's why the student will not be get confused, sir. You are talking about the table schema, but in the book it is written about that is database schema. Why? In database, suppose we have only the one table. So a table itself become a database. So its schema will be represented by the database schema. So same thing we can say the database schema is mostly preferred or referred to as a table schema. So that's why you are not required to confuse over here. So this is an example of the table schema and database schema. Now, is it clear to all with this example?
Yes,
Yes,
sir.
sir.
Or any doubt? Any doubt? You have any doubt? Then you can please ask me.
No, sir.
Okay, so I'm just staying connected with this slide, and you can see this is the table. So you can see table, we have the filter table, guardian table, setting table, student attendance table, student guardian table. So in this database we have the number of the tables. Okay, so this is the collection of the tables, or database will be the collection of tables. Now in this table, this is what? This is our first record. Okay, so this is our first record. This is my second record of the student table. Okay, so this is my second record. Now first name, last name, email address, student ID, label, room, and special circumstances. These are what? These are my the field name, or these are also known as the attribute. Okay, in a short I can write in like this one, attribute name. Okay, so a table is a collection of the rows and columns, and rows represented by the records and columns represented by the field name or attribute name. Now, is it clear to all what is mean by the schema? Yes, please tell me, is it clear to all?
Yes, sir.
No, no doubt? Yes, please tell me, no doubt?
No, sir.
Okay, so in the student database, on the top side, you can see in the student database, we have these tables. Okay, so this is a good example from the MS Access I have taken to you. Okay, so this is a real example I have shared with you. Now, shall I move ahead to my next part?
Yes, sir.
Yes, sir.
Okay, so there's a beauty of the MS Access 2019, or whenever you need to open the record, so just click on the open button, so you can see the entire record like this one. Okay, so individual record you can see like this one. So I have the point over here to here inform the images, and you can see the first name is Virendra, last name is Kushwa written over here, student ID and level and other details is like written over here, which is already entered by me into the previous slide part. So I am skipping this slide. Okay. So is it clear to all about the schema? So few terms we have, that is a sub schema. So I'm just reading all these points for a benefit purpose. So first point, database system have the several schema. It means it means student database. In the student database, what we have in the student database, we can have the multiple tables. Okay, so a student database, what we have the student record. Okay, student record schema or table, we can say student record. Okay, we can have the attendance of the student record. We can also have the marks schema or marks table. Okay, so these are the three schema we have in the student database. So this point you need to keep in mind while learning the database. A database system have the several schema and partition according to level of the abstraction. So once it is clear to all the different level of the abstraction, then you can just adjust all the schema along with your database. So this is the point you need to keep in mind. Now, next point is saying that the physical schema describe the database design. Of course, so here this is an example of the physical schema, because it's physically I can see over here, I can do work. What the information that is to be entered by me, that is Birendra Kushwa and the 24 at gmail.com. So I know what value I'm putting. So that this is maintained by the physical level. But how it is to be stored into the my computer system, that I don't know, and that is known as the logical level. And this is the concept which is known as the data abstraction. So this is the concept which is known as data abstraction. So in the physical schema, describe the database design at the physical level, and the logical level describe the database design at the logical level. So this is an important point you need to keep in mind. And anyone can ask the interview at which level, which kind of the schema will be designed. So you should be remember at the physical level we need to define the or design the physical schema, but at the logical level we need to define the logical schema. So this is the point you need to keep in mind. But in the database, we can have the multiple schema. Okay, so we can have the several schema. So at the different view, different levels, these schemas are also known as the sub schema. Okay, so this schema is also known as the sub schemas. So in sometimes anyone can ask the question for the confusion purpose, why what is the role of the sub schema? Okay, so sub schema are the schema which is represented by the different people as per the requirement. So according to you, I am just getting the information only the movies related. So the movies related information I am getting from the main database. So that is the information which is displayed by the database system. So that schema or that information, that layout or that structure will be the my view. So that is the schema one. But according to you, we are looking for the educational information from the same database. So that part will be represented by the only the education details. And here we have the different schema from the main database. So that's why it is known as the sub schema of the sub schema from the main database. So that's why we have the here term that is a sub schema. So this is the point. Now in these 3 points you haven't doubt, then you can ask me. Yes, please, one by one you can ask me. You haven't doubt. Yes, student, please go ahead for asking the question. You are free to ask any question. If you don't have any doubt, then I can move ahead. Please tell me.
Yes, sir.
Yes. What is the problem?
No, sir.
So, am I expecting or am I expect no student have any kind of the problem? Then I can move ahead. So 60 students are not having any problem for understanding the database concept, then I can move ahead. Are they getting something over here or just passing their time? Yes, Bansika Samani. Yes, Bansika, are they here? Bansika Samani. Okay. Next is Meghna. Meghna, are you there? So Meghna
Yes,
Chandwani.
yes, sir.
Yeah,
Yes.
Meghna, are you getting something over here or just you're just spending your time unnecessarily?
Yes, sir. Getting.
Are you getting something over here?
Yes, sir.
Okay, shall I move ahead or do you have any doubt? Then you can ask me. Okay, Vansika, I think your mic is not working, so no problem. So you don't have any doubt, then you can type no here over here if you don't have any doubt. But you have any doubt, then you can ask any question from the chat box. I'm waiting. Please tell me. No doubt. Okay, thank you so much, Vansika. So I'm moving to the my next slide. That is this part. So this part we have already discussed, that is a physical layer, conceptual layer, or external layout view. So we have already discussed with an example. So I'm skipping this slide. Now next point we have, that is the what is the independence of the database. Okay, before independent database you need to understand this concept in simple way. So I have just highlight the such part which is most important part of understanding database, data independence, that is a property of the database management system. So data independence is what actually? So data independence is defined as a property of the database management system that helps you to change the database schema at one level of the database system without requiring to change the schema at the next higher level. It means if you're doing any changes into the physical layer, then it should not affect to the logical level. So it means the information what we have the different level will not affect to the another level, and this is known the data independent. Of course, data independence means data will be independent from the each and every level. So here we have the term that is the data independence, and it is categorized into the two different levels or two different forms. Those are physical data independence or logical data independence, of course, as according to the its level. So based on its important two levels, those are the physical and logical. We have the two kind of data independence level. So let me explain once more about the this data independent definition. Data independence means data will be independent from one level to another level, and this is the property of the database management system. This defines that if it is independent from each other, then if you're changing something at one level, it should not affect or will not affect to the another level. So this is the only the simple definition. So this is the point, my from the data independence. Now you haven't doubt, then you can ask me, please. Yes, in this slide you haven't doubt. Any student who is having any doubt over here, then you can ask me. No, no problem.
So can you explain once again, sir?
Yeah, yeah, I can explain in simple, with simple example, but let me explain through the definition, definitive way. This is a property of the database management system. As we know, we have the three different levels: physical level, logical level, and view level. Suppose we are changing something at the physical level, then it will not affect the logical level. So data, the information what we have at the physical level will not be changed to the logical level or view level. And this is what, this is known as a data independence, and this is a property of the database management system. So according to its level, we have the two different kinds of data independence. Those are the physical and logical level. Let me explain to a simple example. You have a Facebook account. Okay, I have the, suppose I have the 500 friends into my Facebook account. Okay, but I don't like you. Okay, I don't know what is your nature, but I don't like you and I don't want to be a part of the my friend list. So I will remove you. So when I will remove you from the my friend list, then other my other friends will not be removed, and now my other friend will not known to about this part to to whom I am removed. Okay, so if I'm removing someone, so my other friend will know about this part. So this is the different. They are independent from the each and every label. So this is the same thing we can over here into the database management system. If you are doing something into the physical level, then it does not affect or it will not affect uh, at the logical level. So if you are changing anything at the logical level, then it should not or will not be affected at the view level or physical level. And this property is recognized by the data independence. Yes. Now tell me, now any doubt over here, then you can ask me.
Clear, sir, clear.
Okay, please let me know it is clear to you. So I have the real example in my coming slide, then you will understand in more detailed way. So that's why I'm asking. Now tell me. No doubt in this definitive part. Should I move ahead?
Yes, sir.
Okay. So level of the database already we have seen physical level, logical level, conceptual level. We can say external level means view level. So logical independence will lie between the external or conceptual level, and physical level and conceptual level is just having or maintaining by the physical data independence. So physical or logical independence is always saying that whenever you are doing anything into a different level, it should not affect on the another level. So this is the only the level of the database, as I told you so many times. But where it lies, you need to keep in mind. Okay. So this is only the showing that only the place where the logical and physical data independence to be maintained. So now this diagram is very simple diagram. From this diagram, you can ask me, or shall I move ahead? Yes, please tell me. Yes.
Sir, can you explain the external level?
External level means the view level. So it's only the name. It's only different name only. It's a naming convention, nothing else special. This is recognized
Okay,
by
sir.
the view level as we have seen, or as we have seen, and this conceptual level is also known as the logical level. Okay. Only the naming convention, nothing else. So no doubt. Then can I move ahead?
Yes, sir.
Yes, sir.
Okay, so in the physical data independence, rather than the theoretical part, you just need to focus on the highlighted part. But I have put it over theory because it's necessary part for understanding purpose. So in the physical data independence, you can say it allows you to provide a logical description of the database without the need of the specify the physical structure. Now, can anyone just tell me more detail about this highlighted part? Now you can see physical data independence is lies between the physical level and conceptual level. Okay, so we have the definition of physical data independence over here. Now, tell me this highlighted part. What did you understand? Please do fast. Just tell me, anyone. If you are saying wrong, it doesn't mean, but you are saying something that will be good.
Sir, it means it is independent of logical level. Sir, if we made any, you can say, changes in schema of physical level, then it will not affect logical level.
Super answer. Thank you. Is giving a nice answer. Suppose we have a schema. In the schema, we are updating something. In the schema, we are updating something. Then the logical description of the database will not be affected. It's a simple thing. Na? Suppose I can take a real example. Truly speaking, student example I can take in the student database student table. We have the student number, student student name, student roll number, and his or her age. Okay, and there's no problem. Is it now physical data independence? I can tell you in a simple way. Now tell me student name, sorry, student number, student enrollment number, student name, student roll number, and his or her age. These are the three different tables, three different attribute or fields we have in the student table. Now this could be recognized by the schema. Now tell me, am I right? I can draw over here like this one. Yes, please tell me student name, roll number, and his or her age. Now this is the three different attributes we have the student schema. Okay. Now tell me any doubt over here in this example. This is the physical schema I can say. This is the example of the physical schema. Can I say?
Yes, sir.
From the most of the student, is it physical schema? Is it physical schema? Yes, please tell me, is it physical schema? Yes, please tell me, is it physical schema or not?
Not.
Why not? How did you say it is not a physical schema?
Sir, because it's showing some attributes. It's
My dear
logical
friend,
representation.
my dear friends, I already told you on my previous slide. The physical schema is saying that what we are designing in the physical way, and we are using the physical way. In the physical way, we are designing. This is a student name, it is a roll number, this is a age. This is a physical schema. Please do not get confused. This is a physical schema. Now, is it clear to all? This is a physical schema.
Yes, sir.
So now tell me any doubt over here in this physical schema. Okay. Now please, I need the answer. I need the answer from the other all the students. Please tell me any doubt.
No doubt, sir.
Okay.
It's clear.
Okay. Is it clear to all?
Yes, sir.
Okay.
Yes.
So
Yes, sir.
okay, good. So in the student schema, I'm speaking to all once again. This is the physical schema. If I give you the question to the examination, draw a physical schema of the student. Okay, this is the confusing kind of the question I will give you into the different way. Then you have to design this is the student schema. Okay, this is a student schema, and this is a physical. Okay, this is at the physical level. So we are designing. So I'm putting the student name, his or her age, and his or her roll number. So this is I have written over here. Okay. Now I'm putting the roll number 1. Student name is X. His age is 26. Okay. I'm putting the another record that is a 2. Student name is Y, and his or her age is 22. Now this is the third record I'm putting over here. Student name is Z, and his or her age is 18. So how many tables we have? So how many records we have? 3 records. 1, 2, 3. How many columns we have? 3. Roll number, student name, and age. So this is completely representation by the physical schema. Now this is the best example for the physical schema for understanding purpose. Now any doubt over here? Yes, please tell me. Any doubt?
No, sir.
No, sir.
Okay, good. Suppose I just need to alter. Okay, please remember the words, technical terms. If I need to alter or modify, I need to alter or modify this table, or I've forgotten, I should include the gender of the students, included into the this table. So I'm just adding or alter my table, putting the new column name that is gender of the student. So I just put it over here. That is gender of the student. I just forget it. So I have added a new column name or new attribute over here. Okay. So if I'm doing something into this physical structure, okay, physical schema, if I'm doing or updating the physical schema, the my all values will be remain as it is 1, 2, 3, x, y, z, 26, 32, sorry, 22 and 18. Will it be changed? No. Will it be changed? Please tell me, will it be changed? No. So logical value or logical information which is already put it while creating the information or while creating the table, It is already updated or it is already given, so it will not be changed, it will not be affect on the biological level. So that's why we can say there is a physical data independence. Now there's an example. Now is it clear to you all?
Yes, sir.
Yes, sir.
The previous value which is stored by me is already stored into my database. That will be as it is. That will not affect. That will not be changed. Okay. So if I'm updating the physical schema, then rest of the information will be as it is. Now is it clear to all?
Yes, sir.
And this is example of the physical data independence is, and this kind of example is not given to the any book. So in most of the book, only the theoretical is given. But I am explaining all the concept via the real life example. Then you feel you can understand this concept in simple way. No, none of the books I have just read out so many books about the database. I found none of the book is explaining the example of the physical data independence in very well manner. Just I am just putting the all the things in simple concept. So this is known as the physical data independence. Okay, suppose we have the gender. Okay, no problem. So gender I'm putting the male, female, and just male randomly. Now I'm come to the reverse part of the logical data independence. Logical in the logical independence, suppose if I need to update the student name. Okay, this student name is not X, his name is W. Okay, or I can update the age of this student. Okay, that should be the 20 rather than the 22. I'm updating. If I'm updating the some stored information that is to be stored into my database or my table, my column name or the size of the my this stored information will be will be changed. No, that will be as it is. The age, if I'm updating 20, 22 to 20, then age will be age column will be as it is. It will not be changed into the another name. So it means the logical level and data logical data independence and physical data independence are most important part to explain to elaborate your idea with respect to database. So physical data independence and like physical data independence, logical data independence is also having the same thing. If we are doing any changes into the logical level, then it will not affect to the another level. Okay, so this is my point. Now, is it clear to all this concept? This concept that is a physical data independence and logical data independence. Is it
Sir,
clear to
I
all?
have, excuse me, sir. Sir, I
Yes.
have a doubt between logical level and physical level.
Yes. Tell me what the doubt you have.
Sir, I mean to say that the software that we use to create the database, is it a logical level or a physical level?
Since while putting the information like creating a table, while updating the table, modifying the table, and that is done at the physical level. But while inserting the record, while updating the record, while deleting the record is a part
But
of the logical level.
but sir, I have a doubt that the storage device like SSD or HDD that we are used to store that database into it, is it a
No,
physical
no.
level? Yeah.
No, no, no. At the no, you are looking for the physical device. Okay, you are thinking that at the physical level we are storing something into the physical device. That is a physical level. Okay, that is a
Yes, sir.
medium only. That is a medium only. But at which level means at how we are storing information, and that is known as the physical level. It doesn't mean what the physical medium you have. That could be floppy drive. That could be pen drive. That could be CD-ROM. That could be your hard disk. It doesn't mean. Now, is it
Okay.
clear to you? Is it clear to
Yes, sir.
you?
Yes,
Okay,
yes,
so
yes. Okay.
you have to worry about your technical terms, and you are asking the general question that should be. Okay, thank you asking this question because this is general question, and most of the students will confuse about the physical level means we are talking about the physical devices. Okay, that could be, but physical levels means how data to be stored and where data to be stored doesn't mean data could be stored in any board and in the CD-ROM directly and floppy drive, CD or hard disks or any secondary device as well. So it doesn't mean okay. It could be stored as well in the primary memory. Okay, so it doesn't mean.
Okay,
Now,
okay.
so this is the
Hmm.
idea about the physical data independence and logical data independence. So now, is it clear to all what I mean to say that I have explained the data independence and physical data independence and logical data independence. So what is this? This is a property of the database management system. If you are changing something into the logical level, then it will not affect to the another level. And if you are changing into physical level or physical schema, then it will not affect to the another level. Okay, so this is the point we need to keep in mind while learning the database management system. Now, is it clear to all?
Yes, sir.
Any
Yes,
any
sir.
doubt? Any doubt?
No, sir.
Now shall I move ahead, or yes, student, really you have any doubt, then you can ask me. And student are
सर
asking the question in this. Yes, please tell me.
सर बेसिकली अपन जो डेटा एब्स्ट्रैक्शन का यूज करते हैं उसका मेन एम यही होता है ना कि जो यूजर डाटा यूज कर रहा है उसको मालूम नहीं होता कि एक्चुअल में डाटा कहाँ होता है।
आपके शब्दों की अगर मैं बात करूं तो बहुत क्वेश्चन को आंसर को मैं बहुत सिंपल शब्दों में समझाऊं तो यही है कि फिजिकल लेवल ये कहता है कि आप डेटा क्या स्टोर कर रहे हो। जैसे कि मैंने नाम स्टोर किया राम, ओके, या एक्स, तो ये मुझे पता है, यूजर को पता है एक्स है, ये एक फिजिकल थिंग है जो स्टोर कर रहे हैं। फिजिकल मतलब कोई टच नहीं कर रहे हैं हम लोग। जो कंप्यूटर सिस्टम की बात करें ना डिजिटल वे में, हम फिजिकल क्या स्टोर कर रहे हैं, पर एक्स कैसे स्टोर हो रहा है ये हमें नहीं पता। वो कौन जानता है? वो कंसेप्चुअल लेवल या लॉजिकल लेवल जानता है। एंड वो कौन मैनेज
जैसे
करेगा? वो जो डेटाबेस
जैसे
कंपाइलर है वो।
हाँ सर, जैसे आपने सर प्रीवियस क्लास में बताया था आईआरसीटीसी के बारे में, तो उसमें आपने जैसे अपन इसका बोले एग्जांपल, तो अपन अलग अलग व्यू लेते हैं उसका। जैसे आपको कहीं और जाना है, मेरे को कहीं और जाना है, तो आपको कुछ अलग व्यू शो होगा, मेरे को अलग व्यू शो होगा, तो वो उसका हो गया व्यू लेवल। देन उसके
नहीं,
बाद
व्यू लेवल के लिए देखो ऐसा है कि आपके पास ये बताइए कि वीटॉप पे आपको कोई राइट्स होते हैं कि क्या आप अदर स्टूडेंट की डिटेल देख सकते हो?
नहीं सर, वो तो सर वो हो गया ना अपना रोल बेस्ड एक्सेस कंट्रोल।
हाँ, वो नहीं, एक्चुअली वो रोल बेस्ड एक्सेस कंट्रोल है। दैट इज द एग्जांपल ऑफ द व्यू लेवल। सो ओके, व्यू लेवल पे हमको क्या लेवल
यस
मिला है,
सर।
किसने हमें
हाँ,
राइट्स है। सो हमें हमें
और
वो चीज़ व्यू
उस
व्यू व्यू है कि नहीं है, वो चीज़ हमें व्यू है कि नहीं है।
और सर वो अपन को वहां पर टेबल के फॉर्म में दिखता है सर, वो हो गया उसका लॉजिकल। क्योंकि सर जो एक्चुअल में डाटा पड़ा होता है अपन को खुद को नहीं मालूम होता ना कि ऐसे तो पड़ा नहीं होगा वहां पे हार्ड ड्राइव में डाटा के टेबल्स के फॉर्म में, तो उसके लिए अपन लॉजिकल का यूज करते हैं, तो अपन को टेबल्स के फॉर्म में दिखता है वो।
ठीक है।
और जो उसका फिजिकल होता है उसमें सर एक्चुअल में डाटा पड़ा होता है, जो कि
नहीं,
टेबल्स के
फिजिकल
फॉर्म में नहीं होता।
वो टेबल में नहीं होता, वो स्टोर होता है। ठीक है, पॉइंट को ध्यान
यस
सुनिए,
सर।
वो स्टोर होता है। और जब आपको आउटपुट नजर आता है वो आपका लॉजिकल वे में नजर आता है। ठीक है, जो टेबल की बात कर रहे हैं वो टेबल के फॉर्म में आता है। पर लेकिन फिजिकल स्कीमा ये कहती है कि उसके एट्रीब्यूट्स क्या हैं, तो क्या फिजिकल क्वांटिटी जिसमें हम स्टोर करेंगे उसको। दिस इज द पॉइंट।
मतलब सर फिजिकल स्कीमा और फिजिकल लेवल दोनों अलग अलग है।
नहीं नहीं, फिजिकल फिर कंफ्यूज क्यों हो रहे हो? देखो ये पढ़ो ना। फिजिकल यहाँ पढ़ो। फिजिकल डेटा इंडिपेंडेंस हेल्प टू level from the internal or physical level, and this level is done at the physical level. तो फिजिकल स्कीमा, फिजिकल डेटा इंडिपेंडेंस या फिजिकल जो भी काम करेंगे वो आपके फिजिकल, हाँ, और फिजिकल स्कीमा जो बनेगा फिजिकल लेवल पे बनेगा। अच्छा, वो सिंपल एग्जांपल समझाते हैं। ठीक है, आप बाजार से सब्जी लेके आए।
यस सर।
Yes, sir.
ओके, बाजार से सब्जी लेके आए, so your mother is cooking vegetable. Okay, so vegetable we have brought from the this any market. Okay, so
ओके सर।
you have the raw facts, okay, but you don't know how to use such, right? And that is a physical thing. You know was only the this is the data. Okay, this is the vegetables we can use, but how it is to be prepared, and that is some algorithm, and that algorithm that is to be managed by the database management system. So we have the compiler, interpreter, other things. Okay, that is internal process, and that is to be managed by the logical level only. Okay, so as
सर
output
मींस यूजर कैन सी, सर मींस यूजर कैन सी फिजिकल लेवल।
user can see the physical level. User can
सर
see
व्हाई
only the
कैन,
physical.
सर
User
योर
can
वॉइस इज ब्रेकिंग।
Okay, user can see only the physical level, and after interpreting its physical level, it has the various view levels.
सर योर वॉइस इज ब्रेकिंग।
Now, hello. Now it is clear to all. Hello. Now, I'm getting your voice properly. It means from my side, net is okay. Okay, let me take the real example. Okay, can I take real example?
Sir, could you show the 3 level of data abstraction?
This you're talking about this one. This one. This diagram, or you are looking for the practical part?
Sir, yes, sir, it's a that diagram. Sir, here a user can see the data from the logical level, not the physical level.
No. Yes, data will be shown by the system from the logical level, and logical level is intermediate level. So the information which is completely passing from the physical level to view level, but logical level play important role that what the user requirement. So as per the user requirement, what the information to be displayed. So without the logical level, how it is to be interpreted. So just in logical level, just kind of the processing part. In between intermediate, we can say. Suppose you have any problem, so you can't directly meet to the vice chancellor. Okay, first you need to contact your property. Okay, so proctor. Okay, so the proctor is a kind of the logical level. So he will interpret your problems, and he will identify your problem, and then he will and communicate with the our channel. You can't directly see the physical level, but what happened internally, physically information is shown to the us in the logical way. So it seems that we are looking for the physical. So what have in the logical information we are looking, and we are having the logical information, but it seems that we have the physical information that is to be stored, like ram, other names, other detail are stored into the logic, displaying to the logical level, display into the logical level, but it shows that if this information is stored, so that is actually represented by the physical level. So user can understand this is the physical schema. So physical schema represented that overall layout, overall structure of the table.
Okay, sir.
Okay, so I think let me explain through this part. Now, see, just I have a few example over here. Now, example that changes under the physical data is independent. So you can read out over here. I've just put it the all the concept in simple way. So modifying the file organizing technique into database. So what the information we are modifying? So physical data. So if you are changing something into the its actual structure, then the information which is stored into the values form, just like name and xyz and age 26, 20, 22 and 18. So these are what these value will not be changed. Okay, so this is a physical data independence. Physical data independence is completely different from the logical. Can you tell me, suppose you in your house you have the 2 floor, and you are planning to construct a 3rd floor, then your other rooms will be affected, or the size of the other room will be changed? No, that will be as it is. Your kitchen size or kitchen utensil, what you have, you are using, that will be as it is. That will be as it is. So you're changing something to the physical schema, physical level, then other level will not be changed. Okay, and we have the 4 floor in our house or in building, and we are planning to shift the phrase or almara one place to another place. Then floor will be shifted? No, that will those floor structure will be or size will be as it is. So this is the thing. Yes, this is the point. Now tell me, any doubt?
No, sir.
So, so switching to a different data structure. Firstly, I store the information in the stack manner, but I'm planning to store my information in the quick manner, queue manner, or a tree manner. Then I can store. Then something will not be changed. Something which should not be changed. This is the independence. Independence means both level are independent from each other. Okay, so this is the point. So here we have the example: changing the access method. Changing the access method means you have the right now the only writing read property, read facility, read privilege, but I'm changing you, you can update the information. So this is the access method. So I'm just giving the right, you can also update, you can have the right privilege. So this, if I'm using something like this one into the physical data independence, so it will not change its logical level, logical values. And modify indexing. Indexes we will see into the practical way, and that is a part of the creating the data definition part. Okay. So changes to the compression technique or hashing algorithm. I think into data structure you have studied the hashing algorithm. Okay. So in the hashing technique, if you try to compress your something, then your actual information will not be changed. Like you have the huge amount of database. You try to compress your information, okay, for keeping the information to shorten way or in shorten way into the normal size. Then your actual information will not be changed. So this is also another example. And changes of the location from one device to or one disk to another. I have my student database, and if I need to show my project to my another college, am I just bringing such a database into my pen drive, and then I'm inserting pen drive to another laptop and desktop, then I'm copying or transferring the such a database. Then the actual stored information or actual schema that will not be changed at any level. So this is what this is the physical data independence. So if you're doing anything, then at the different level or at any level, then other level will not be affected. This is the point, and that known as the physical data independence or logical data independence. Vice versa, we are doing anything into the logical data independence, the logical level, and physical schema or physical level will not be changed. So this is the point. Here we have the example of the logical data independence. Like here, like I'm merging two records. Okay, I found that is these two records are common for all the things, so I can merge these two records. So I'm just changing its logical at logical level. I'm just changing something. Then physical schema or physical structure of the such thing will not be changed. So that is merging the two records into the one. I found that is okay. Both students belong to the same father name. Okay, so I can merge their father name into the one column. So I can do. But if I'm doing this one, then other things should not be changed. Now breaking the an existing record into the two or more record. I found that is a 39 records, but I found that is one record is mixed up or inserted in twice time into the 30th position. So for the 30th record, I can break up into the two or more than two records or sub record we can say, but its actual physical schema which is showing that the actual list of the attribute will not be changed. So that is the example of the logical data independence. Just tell me now here any doubt?
No, sir.
Here we have the important point that is what is a relational database. So relational database basically is kind of a database. A relational database is a kind of a database which defines that this is a relation. But how we can say it is a relation? A table is known as a relation. As I spoke you, table is a relation. Table is a relation means table can be table. Why it is known as a relation? Because another table or another schema will communicate to the another schema for sharing the information. If there is nothing will be common between you and me, then how to communicate? So there is a relation between you and me. Why important part that is course. So we have a common property by which we can share our information or we can make in a relationship. So that is known as the relation. So the word is coming from the relation is that is from the relations. So what is a relational database? A relational database is a type of the database that store and provide access to data points that are related to the one another. Rather than much theoretical, it is better idea to understand simple example. I have a schema that is a customer. This is my customer schema. And in this customer schema, I have the customer ID, name, age, house type, and city. What are these? These are the attributes name and field name. These are the attribute name and field name. And there's another schema we have that is a order. We have the other schema that is product, and we have the other schema that is vehicle. And which customer purchase a wheel? So in the vehicle schema, we have all the details about the vehicle. That is the vehicle ID, vehicle type, and model and color. And we are integrated with customer ID to identify or to know that whose customer purchased the particular vehicle. So we just need to put only the his or her customer ID. So this customer ID will be connected with the this customer ID. So this is a common thing between these two schemas, customer ID. So we can easily identify that whose customer who's purchased the bike or car. So this is a relation. So through the simple thing or through the simple or common attribute name or common field name, we can communicate or two schema can communicate within by making a relation. So that's why it is known as a relational database. So relational database is a kind of a database. That's why it is written over here. It is a kind of a database and which make a relation with the another schema. So here we have the four schemas: customer, order, product, and vehicle. So product, we just keep the information about only the product. The question is you must have, so rather than the putting the full schema, we can have the multiple schema. Sorry, single schema. We can keep all the details. You can do, but definitely that will not be normalized. That will not be simplified. This is what you need to keep in mind. For the simplification, it is better idea to make your work into the simplification so the troubleshooting will be easy. And to avoid the redundancy and inconsistency. So to avoid the redundancy and inconsistency, we have this kind of a thing. So this is a relational database. Now tell me any doubt over here? Relational schema. Yes, please tell me any doubt.
No, sir.
Okay. So if I give you any exercise, then can you design any schema? Suppose I'm giving any exercise, then can you design any schema? Yes, please tell me. Suppose I'm giving. Okay. So tomorrow I will give you an exercise in the class during the class, and I need to answer from the one by one from the students, and I will call their name. Okay. So here we have the term database language. Before jumping the database languages, I have the another part, and which is a necessary part, and which help you to that how to do the practical. From the database language, we will start with the practical part, and since it is not a part of practical, but it shows how to start our work. And before that, I'm using the MySQL tool. Okay, so you can use any tool, but query will be the same. So there is no issue about that part. You can use any query.